All right, design heating load part 3. In this little video, we're going to continue looking at design heating load. We've already looked at the heat loss to transmission, QT, and what those units are. Now we're going to look at QA, the heat loss associated with air movement. QA is a little tougher for people to conceptualize for some reason because it's dealing with volume and not square footage of a surface. So for some reason, students have a little more trouble on this one. But it's the same idea, is how much heat do we lose associated with how much air is moving in and out of our houses. So let's go to the board, and let's remember this. Design heating load equals QT plus QA. It has units of BTU per hour. So let's look at QA. Here's the formula for QA. It's called air heat capacity times air flow rate times delta T. Same delta T that we use all the time, that we used in the previous one. This is new to you, this is new to you. Air heat capacity is a constant. It's always the same. Once you learn it, it never changes. It basically refers to how much heat can a certain volume of air hold at a certain temperature. And I'll show you what those units are. Airflow rate is simply saying how much air are we losing out of our houses. So if we know how much heat that air can hold and we know how much air is moving, then we can figure out how much heat we're losing for that. All right, so air heat capacity, and remember QA, we're still winding up BTUs per hour. There's no BTUs in airflow rate, all right? Rate is something over time. So let's start with what we know. Well, that's degrees Fahrenheit over 1. Airflow rate. Well, how much air is moving over a certain amount of time? What period of time are we looking at in this equation? We're looking at hours. So let's put hours, airflow rate, something per hour. How do we measure air volume? It's cubic feet. So cubic feet per hour. All right, so from there, you can figure out what air heat capacity is. If we've got BTUs per hour, well, there's no BTUs here, so air heat capacity must have BTUs, and since I told you it's talking about how much heat air can hold. Will there be an hour over here? No, because we need an hour, and we've already got an hour. Will there be a cubic foot over here somewhere? Well, we've lost our cubic foot in our final answer, so we have to have one to cancel it out. And since this one's on top, this cubic foot must be on the bottom. Do we have a degree Fahrenheit up here? Nope. Well, we do here, so we have to get rid of it. This is on top. There must be one on the bottom here. So there it is. Air heat capacity is the amount of BTUs a cubic foot of air can hold at a certain temperature. So let's cancel things out and see if we wind up with it. BTUs per hour. We get rid of cubic feet. We get rid of degrees Fahrenheit. And we wind up with BTUs per hour. So that's really simple. So this is a constant. We look that up. We've already shown you how to determine this. Where does airflow rate come from? That's something we're going to look at. We have to measure that. For airflow rate, we're going to do a test. We're going to hook a big fan up to a door in a house, and we're going to pull air out of it at a certain pressure, and we're going to measure it. And that'll give us a number. So we'll get to that later on. For now, start memorizing this equation as well.